At this talk, we are welcoming Samuel Peterson. He is a business development manager for the Swedish Space Corporation. The SSC has the most advanced commercial ground station network in the world, supporting the requirements of NASA, ESA, ISRO, and privately funded missions for more than 2 decades. He heads up customer support for lunar missions globally and the full range of mission profiles for customers in the Canadian region. Prior to SSC, he served as ground operations engineer for the ESA, where he led a global team of teams during the launch and early orbit phase of 10 ESA and partner agency spacecraft. He started his career supporting the U.S. military, first as an enlisted satellite communications tech, and then as a contractor with assignments in Japan and Germany. He is sometimes called Professor Peterson by students of Embry-Riddle Aeronautical University, where he's been a member of the adjunct faculty for 10 years. Please welcome Samuel Peterson.
Thank you for that kind introduction, and thank you to everybody at the Moon Society who has set up this great conference for us. I'm also joined today by another colleague from SSC, Henrik Johansson, and I'll let him say a few words about himself because I haven't actually prepared an introduction for Henrik. So, Henrik, please.
Thank you, Sam. So my name is Henrik Johansson. I've been with the Swedish Space Corporation for 2 years now. I started out on the satellite side of operations with this global network that we have the following satellites. Recently, this year I moved over to Science and Launch Services that I will talk more about during the presentation. And prior to SSC, I have a background in the defense and telecom sector.
So welcome. Our presentation today is commercial services for lunar missions, past, present, and future. I'm Sam, and Henrik is my co-host, and we're from the Swedish Space Corporation. I'd like to start off by talking a bit about Apollo 12, and I can hear some of you, thinking, "Hey, Sam, Apollo 11, that's the one where we walked on the moon first." But I want to talk a bit about Apollo 12 because of some of the things that we can see right here in this picture. So behind the Apollo 12 landing site there, you can see Surveyor 3, which was actually 177 meters from where they landed. And one of the things that they were practicing was precision landing. Another thing they were practicing was autonomous landing. And we talk about autonomous systems being something new, but I mean, they were testing autonomous systems back on Apollo 12 in November of 1969. But more important for us here at SSC, the astronaut you see in this picture is Pete Conrad. He was the commander of Apollo 12, the third man to walk on the moon, and he was the founder of Universal Space Network, which is now called SSC Space US. So he brought about our global ground station network, creating a company intended to be the telephone company to the moon and to space. And we are continuing on his legacy. And here's some more of the legacy of SSC's involvement with lunar and deep space missions. I'm not going to go through all of these. I will mention a brief little bit about the 3 that we've got pictured here, though. So the Lunar Reconnaissance Orbiter, I'm sure a lot of people have heard of, and SSC has been supporting this one since it launched in 2009. So for more than a decade, we've been supporting NASA's LRO. We also helped with the development of LRO and some of the techniques that are used for the communications and navigation of this mission. SMART 1 was ESA's lunar mission. This was actually earlier than LRO, about 2003, 2004. That was the period when SMART 1 was in operations. And SSC developed the spacecraft. We used to build spacecraft in Sweden. We spun off that part of our business some years ago. It's now called OHB Sweden. But we also have engineers that operated the spacecraft for European Space Agency in Darmstadt as contractors to the European Space Operations Center, and some of them still work in our engineering services division. And of course, most recently, Beresheet was SpaceIL's lunar mission, the first privately funded lunar mission last year, and the SSC Global Ground Station Network provided the communications for their mission all the way up until the last signals were received from the spacecraft. Here are some lunar landing sites. I'll let Henrik talk a little bit about why these were chosen by the science team and highlight some of the things that are coming up here.
Yeah, I mean, of course, like we've talked about these two days, a lot of focus is on the South Pole, and I mean, we have the Apollo landings around the well, yeah, the historical landing sites also, but we see an increased focus on the South Pole, like most other people have already talked about these 2 days.
It's worth noting that SSC is not intending to do any of these landings. You'll notice that these are all other companies' landings. We're here to talk about commercial space services and what SSC can provide for companies that have big ideas for going to the moon. So this is the SSC organization. I didn't want to show you a big company organizational chart, but mostly I just wanted to talk about the 3 different divisions of our company, which all do different services, and we'll talk about them in more detail. I work in the Satellite Management Services division. This is our global ground station network, and as Henrik already mentioned, he works in our Science Services division in ESRANGE, Sweden. And then our Engineering Services division does manpower contracts and software development and systems development, mostly for the European Space Agency, DLR, CNES, and other institutional customers in Europe. And now I'll let Henrik take over, talking more about science and launch services. So just let me know when you need me to advance the slides, Henrik.
Yeah, next slide, please. So I want to start off by going back in time quite a few decades, actually back to the 60s. So this sort of explains where SSC comes from and why we exist today, really. So during the Cold War, Western Europe wanted to show the world that they could do space-related activities just like the US and the USSR. So they formed ESRO, the European Space Research Organization, which is a predecessor of what is today ESA. They wanted to build a space center in one of the member countries. They wanted an impact area over land. They wanted to study northern lights, and they wanted infrastructure to be good and communications to be good. And the choice fell on the city of Kiruna in northern Sweden. So outside of Kiruna is today where ESRANGE is located. As you can see, since the 60s, there's been quite a lot going on there. We have launched over 570 rockets, and 645 balloons have been released there. And there are a lot of other activities as well. Sam will tell you more about our network of antennas, global network, there on ESRANGE, of course. We also have ground instrumentation, scientific instrumentation. We do technology demonstrations, so drop tests over the impact area, for instance. We are currently building test stands for rocket engines, and next year there will be a first orbital launch from ESRANGE Space Center. So there's definitely merit to the statement that this will become the most versatile space center in the world, because there's a lot going on up there. So next slide, please. So for all these balloons and sounding rockets, we have been involved in developing payloads, but not only for these. We have also done it for parabolic flights, for space shuttle, and we can definitely do it for ISS and other platforms as well. Sam already mentioned Smart 1, but we've also been involved in other satellite projects. Odin, Astrid, Viking, and Freja are well-known Swedish satellites. Odin is still operational. I hope it'll make it to its 20th operational year next year. And a colleague of mine was actually just a month ago sending some commands to it, so we're still involved in that project. JUICE is ESA project is the Jupiter Icy Moon Explorer, and IRF, the Swedish Institute of Astrophysics, is involved there, and also SSC. So next slide, please. Yeah, and looking at the at the moon, we see, of course, a wide range of different kind of payloads, scientific payloads or technology experiments, ISRU, or communications. I mean, these are things we have heard over and over again these 2 days. We do full system development for the payloads. We develop everything from support structures and the module itself to power data, and we can do deployables, etc. So mechanical structures as well. we are very familiar with the radiation and temperature from what we've done previously. Of course, the lunar surface, again, like we have talked about these 2 days, will require a lot more with the lunar nights and impacts and dust, etc. But that is something we are currently looking at and working on, because we see an increased interest in the moon. Next slide, please. Looking at the scientific payloads, we have built the experiment modules for, there's a wide range of different experiments, everything from biological experiments to material science or planetary science, and the requirements vary quite a lot, but we basically customize the modules and cater to these requirements. Again, we do technology demonstrations, we've done drop tests, etc. in the impact area outside of ESRANGE. And of course, the wide range of activities that comes with developing a full module, everything from power to communications and onboard cameras, etc. Next slide, please. In our office in Solna in Stockholm, we have a laboratory for manufacturing of mechanics, electronics, for assembly and testing before a launch. There's actually a yard in the building with a glass pyramid where we stack these modules on top of each other before launch. It's kind of cool to see. And we have a clean room, and we can do testing for vibration, thermal vacuum, thermal cycling, and radiation there as well. Next slide, please. And this is Suborbital Express. It's our suborbital sounding rocket ride-sharing program. Basically, we see this as a great platform for trying out new technology before going to the moon, to reduce risks and try things out in a where there's less at stake. Typically on one of these launches, you would get 6 minutes of high quality microgravity. We can do simulated moon gravity on these flights. We had a launch in June last year, and there will be one in next spring. And again, this is as we see it, a great platform for demonstrating technology and reducing risks before actually going to the moon. Next slide. I think that was my part of the presentation. Yeah.
Yes, thank you, Henrik. Thanks. And our colleague from Engineering Services couldn't make it for this presentation, so I will do my best to talk about what the great things that the Engineering Services colleagues do. So as I mentioned before, the Engineering Services, for the most part, they are full-time consultants working at on-site at ESA or at DLR or CNES or other client sites. In some cases, they also build things in their own laboratory and design their own software solutions or their own systems for commercial customers. In the picture on the top, that's actually, I believe that's Eutelsat's constellation of satellites, which they helped to develop a flight dynamics solution for, as I understand. So some of the things that they work on that are pretty interesting are the ISS Columbus Control Center that's in Cologne. They also work on the full scope of robotic missions by the European Space Agency, including Earth observation missions such as Copernicus, the astronomy missions such as XMM Newton and Integral, and interplanetary missions such as the Rosetta Comet landing. They have flight dynamics experts that do orbit determination, especially during the LEOP phase when they have to find the satellite. And they do mission analysis, for the different phases of developing a mission before it becomes a mission. And they do simulations leading up to the beginning of a mission. So before you ever launch into space, the team gets together and trains and practices for routine operations, but also for a number of different contingencies that they have built in. And our colleagues in their science services division are really good at these simulations. And then some of the software products they've made are featured in control centers, flight dynamic systems, and the management of constellations such as the Eutelsat constellation that you see there. And now I'll talk a little bit about our satellite management services. And this is our lunar communications that I'm going to be talking about, but we also do a full scope of mission profiles, especially a lot of Earth observation missions, which is, I would say our bread and butter, if you will. And also we do a lot of launch and early orbit phase missions for GEO, for a number of different mission profiles. So this is our ground station network around the world. You'll see that some of the stations are color coded, whether they're SSC ground stations or collaborative stations. So, but we do have access to a full global network. So depending upon your mission profile, we can usually give you 24/7 coverage for a lunar mission, for example, or for a GEO mission. And for LEO missions, we can get you tracking data at least once per orbit for most mission profiles, and in many cases we can get you data multiple times per orbit. And really, our ground station network is set up around being multi-user and multi-mission, so we can tailor it to any type of mission needs. And we have a intelligent scheduling system that can find the times that your spacecraft needs to be seen and deliver the service as you need it. And this is, again, the ground network that we used for SpaceIL last year, and this is what we're using for upcoming lunar missions that we'll be supporting in the coming years. And this is kind of our roadmap. This kind of gets into the future. I do apologize when we had wanted to show a couple of the exciting R&D projects that we're working on, but internally we decided that it was a bit early because we're kind of in the pre-phase of some of these studies at the moment. But you'll hear from SSC at upcoming conferences about the outcomes of some of our studies, which will feed back into this lunar roadmap that you see here. But what I'd like to point out here is we have kind of a phased approach for how our architecture is going to be developed over the next few years. So right now, we can deliver service using our current infrastructure that's been in use for several years now. And this is what we used on the SpaceIL mission and other missions like SpaceIL, like some of the early CLIPS missions we can support with our existing infrastructure today. Some of the more demanding missions, such as gateway modules and Artemis, coming up in the near future, will require upgrades to our network, especially X-band upgrades and later Ka-band upgrades. And these are things that we already have in the pipeline in our roadmap. And then as we look a little bit further into the future, our phase 3, we want to bring on larger aperture antennas into our shared network. And also we want to introduce new technologies such as optical telescopes, like you see in the picture here. So that, and I can say that some of the R&D projects that we're looking at will involve optical communications, but we see that as kind of a next generation technology currently, a chicken and an egg, if you will. There's a lot of people asking about optical telescopes, but until we have an architecture, we're not going to invest in putting optical telescopes all around the world and find out that we invested in the Betamax of optical telescopes, to use an analogy from VCRs back in the day. And then at the bottom here, you see just kind of a roadmap of some of the missions that we see coming up. And yeah, the little X's that we see there are launches that we think are going to be happening in the future from what we hear in the industry and what we hear with some of our partners. So you can see that there's a lot of not just interest in the moon, but I think we're going to be seeing a lot of missions actually going to the moon in the next few years. It's a very exciting time to be part of the space industry. And that is all that Henrik and I have prepared, and we'd love to answer a few questions in the minutes that we have remaining. Okay, this is from Charles. He says, do you have the capability of 900 megahertz UHF for lunar missions? So currently, no, we don't. That's not one of the frequency bands, I would say, that we are currently baselining to use on missions. That's not to say that we couldn't. So if a customer, that was planning to go to the moon wanted to use that frequency range, we could probably find a way to support them. But currently the missions that we're looking at are mostly in the S band and X band, which is kind of the 2 gigahertz and the 7 gigahertz range, 7 to 8 gigahertz range. That's the frequency bands that we see more customers asking about. So that's what our infrastructure is designed around. And a follow-up question, he asked if there's any plans for Ka-band or laser comm to the moon. So yes, in our roadmap, we're currently, we have some Ka-band capabilities in our network already, but that is part of the upgrades that we're going to have in the coming years. So we're going to have, I would say, a full scope Ka-band to be able to offer global Ka-band service. And then, as I said, we're in the early stages of investigating optical communications, mostly because we want to make sure that we have the right architecture. So it's more of an R&D effort at the moment rather than delivering a commercial service. Certainly once we have the first tests that are successful and we can demonstrate that it works for a customer, then we'll develop a commercial service around this technology. This one's for Henrik. So Graham asks, hi, for the sounding rockets, do you test small sats and do you allow for universities and etc. to try their tech out on them?
Yeah, so actually student activities is actually quite a big part of the activities going on at SRange. We have annual programs with students participating from well, mostly Europe, but also other countries. So this is something that we're doing on a regular basis. I would say we have both balloon and sounding rocket student programs. Small sats is definitely something we could test from a sounding rocket platform. Don't think we have done it yet, but it could be done. And I mean, we have done other payloads with like ejectables, for instance, where so we could do something similar, definitely.
And Harvey asks, he says, who is your typical customer? So, I mean, we have a wide range of customers. We have institutional customers such as, you know, NASA, ESA, DLR, CNES, JAXA, the space agencies of the world, I would say. Then we have commercial customers, and they could be anywhere from like a telecom operator that wants us to handle their launch and early orbit phase, although that's usually not so much the operator as the manufacturer, because the operator would take delivery of the spacecraft once it's in its parking orbit. But SSC a lot of time handles the launch and early orbit phase up until it gets to the parking orbit. Other customers, you know, include a lot of the space startups that are out there now that are doing Earth observation missions, or a variety of other, a lot of low Earth orbit missions, I would say currently. And then, as I said, SpaceIL, that was the first commercial lunar mission, and we see a lot of other lunar missions coming soon, you know, launching soon, and that we're going to see in the coming years. And those will be customers of SSC too, we hope. Any other questions? Feel free to type them or raise your hand, and I can try to figure out how to unmute you if you raise your hand. If you type them, I can read them off like I've been doing for everybody else. I think you can also unmute yourself if you wanted to just unmute and ask a question. That's fine as well. Otherwise, thank you everybody for attending. Thank you for your interest in SSC's lunar services. And actually, we did get one last question. So Grace asks if our companies I mean, we're one company with different divisions within the company, asks if we're hiring, and we do regularly hire, yes. However, like a lot of companies, we're not hiring as much as we normally would because of the current uncertainty with the COVID and everything. But I think we do have, I haven't looked recently, but I did see some announcements for our engineering services hiring in Germany recently, and there were some Swedish positions recently as well. And we recently filled in the US a position, an entry-level position for operations. So our operations, the 24-hour operations is fully trained within our own facility. So we have a training program, and that's like an entry level before, you know, you're an engineer. And we recently rounded out our staff in that regard as well. So if you're interested in a job at SSC, just keep an eye on our website. They also post them on LinkedIn. So follow SSC on LinkedIn and you'll see jobs as they come up.
I think currently there are a number of openings in Germany at engineering services, and we're also looking for a few positions in the UK right now.
Well, with that, I'll just say thank you to everybody for attending. Thank you for the questions and thank you for your interest in SSC, and look forward to maybe meeting some of you in person once we start having conferences face-to-face again. So have a great day.